All right, welcome back. Section 9, 10% of change. Today's objective is to find the percent of increase or decrease. Before we dive into the new material, let's take a look at some practice problems, some review problems. Here we go. Please pause the video here. Try these 4 problems out. I will chime back in after that. We'll take a look at how they should be done and the solutions, all that good stuff. All right, see you in just a minute. Pause the video now. All right, on the first one, $28 jeans, 20% off. What are the directions? It says find the discount or the interest to the nearest cent. All right, since we are finding the discount, that means we're finding the dollars off, not the price we pay. So the discount is going to be 20% of $28. So 0.2 times 28, right? We're finding 20% of the full price. And we get $5.60. What that means is, well, you think about what that means. Are we paying $5.60 for the jeans? No, they are discounted $5.60. So if you wanted to find the price of the jeans, which we did not have to find, it's 28 minus 560. So we'd be paying $22.40 for this particular pair of jeans. So make sure you read the question carefully. Make sure you understand if you're finding the discount or the sale price. We're finding the discount here. All right, let's take a look at the next one. A $54.95 coat that is 15% off. Again, we are finding the discount, the dollars that are taken off of the original price. So we want to find 15% of, that means we're going to multiply $54.95. We multiply and we get $8.24. I did have to round to the nearest penny here. So what that means is the original price was $54.95. And we are taking off of that $8.24. So this would be the correct answer. But if you were asked how much you were going to pay, $54.95 minus $8.24, this code's going to cost $46.71. All right, on the third one, there's a couple different ways to interpret it. So if you don't have exactly what I have, that does not mean you're wrong. First off, we're asked to find the monthly interest. So this did not come up much. If I remember correctly, it did not come up on the IXL, but it did come up in the video lesson that I recorded. So if you need help on the monthly interest stuff, go back and review that. So find the monthly interest, $3,000. That's going to be your principal at 12.5% interest. That's your rate for 2 years. Now, because it's monthly interest, we got to change our time from years to months. Make sure you do that. So 2 years, 2 times 12 months in a year. This is 24 months. So remember, interest is equal to principal times rate times time. So now we just plug in P, R, and T, and you'll see that up top here. Principal is 3,000 times your rate, 0.125 times 24. That's your time, and we get $9,000 interest earned. Now, this would be extremely rare. You would almost never get 12.5% return per month on your money. So what makes me think that this could be interpreted 2 different ways is that, first off, the amount of return per month is astronomical, which would be great if you could get that return. But another way of doing this one would you would have to find, if that is your annual interest, you would have to divide it by 12. So if you divide 12.5 divided by 12, it would be about 1.04% per month. So I'm not going to give you one like this and make you interpret it one way or the other. I'm not out to trick you. So again, if you have monthly interest questions, go back and rewatch that part of the video. There are a couple problems on that. And you can see what like your typical test or quiz question would look like based off of that video lesson from last class. Finally, number 4, find the annual interest, $250 at 9% for 6 months. Keyword here is annual, so this is per year, right? So what is our principal? Principal is going to be $250. What is our rate? 9%. What is our time? Now keep in mind, time, it's annual interest. So we have to adjust this from 6 months to a number of years. Well, how many years is 6 months? It's less than a year, right? It's exactly half a year. So time is going to be 0.5. So 250 is your principal. Plug that in up top here. Your rate is 9%, which is 0.09, and your time, 6 months. Because this is annual interest, we have to change this to years. So 6 months is half a year, right? 6 over 12 is 0.5 or 1/2. We multiply all that together, and when we do, we get $11.25 interest earned. Before we talk about percent change, let's talk about what it means to increase or decrease. So let's say you have $25, a $20 bill and a $5 bill. You happen to drop the $5 bill. It just falls out of your pocket on the street and you lose it, right? So you did have $25. Now you have $20. There's a couple different ways to express this, like in everyday language. You could say it was a $5 decrease, which means you lost $5, right? It's no longer yours. Or you could say you're minus $5. So either of these mean the same thing. If you lost $5, minus $5, or you could say a $5 decrease. So notice if you use the word to describe what's going on, that word being decrease, you don't have to include the positive or negative sign here. The word is the dead giveaway of whether you're going up or down. If you're just using the number itself, you would need to use a negative sign, not necessarily a positive sign, because numbers are positive if you don't see a sign, right? So let's take a look if you go up $5. Same scenario, but now you're walking down the street and you find $5. So you had 25, now you have $30. So that's a $5 increase. $5 increase, or you could say you're plus $5 or just $5. Or you might see a plus sign out front, whatever. Remember, numbers are positive unless you see some other sign to indicate otherwise. All right, so that was not percent change. That was just increasing and decreasing, but these concepts are used in a percent change, especially the words increase and decrease. And what is a percent change? It's the ratio of the amount of change to the original amount. Keyword here is original amount. We are comparing our new value to our original amount. We kind of did that in the example that I just gave you. So we had 25 and we lost 5. So it was a $5 decrease from our original amount. We had 25, we now have 30. So we went up $5, a $5 increase. That was compared to our original amount of $25. So we are comparing the change to the original amount. That's really important here. We are comparing to the original amount. So here's a couple of examples. $120 to $135, that's going to be a percent increase. Now we have not found the percent increase. We will do that later. If we go from $135 to $120, that's going to be a percent decrease. So always ask yourself, am I going up? That's going to be an increase. Am I going down? That's going to be a decrease. So I'm going to show you a couple different ways to do this. Last year, a new bike cost $120. This year, the same bike cost $135. What is the percent change? Now, is it an increase or a decrease? It's an increase, right? So first off, we subtract 135, subtract from that 120. So it went up $15, right? So it's a $15 increase. So we know this has to be positive, or you can use the word increase to signify that it is positive. So now that we know the increase, $15, to find the percent change, that's going to be the percent. So I'll put P for percent, multiplied by the whole. Well, the whole is the original amount, right? 120. And that's going to be the increase or decrease, in this case, 15. So now we divide by the original amount, 120. 15 divided by 120. And we get 0.125 is our percent, which is 12.5. So we have an increase of 12.5%. So let's use the word increase there as well. So it's a 12.5% increase. There you go. Now there's another way to do this, so we can take all this work and put it into one step. So let me show you that. Instead of subtracting and finding the difference and then dividing that difference by the original amount, it's like an equation we can use. I'll show you that now. And the equation is this: new minus old divided by old equals the percent change. Remember, we are always comparing it to the original amount. That's why I say old. You can say original, old, whatever. So let's take a look at this, see if it works out, and if we get the same percentage as last time. So the new is 135 minus the old, 120, over the old, which is 120. 135 minus 120 is 15 over 120. We divide this out and we get 0.125, which is 12.5%. Is it positive? Yes, so that is an increase. If this were a decrease, what would happen is you would have a negative number here. So this would be like if it went down 12.5%, forgot my percent sign. If it went down 12.5%, it would be negative 0.125. And then you would just write 12.5% decrease. You'll see this in a bit. You could also set up a percent proportion. So as a percent increase, we're going up, right? So that's the difference. The difference would be, again, 135 minus 120, we have a difference of 15. We're dividing that by the original amount, which is 120. And that equals the percent, which we're trying to find. I'll put P for percent. Over 100. So you would solve this and you would find out that you have 12.5 for your percent, which is 12.5% when you divide it by 100. So this is another way of doing it, either the percent equation, the percent proportion, or new minus old divided by old. Either way, any three of those would work. Let's take a look at some more. The power bill last month was $4.75. This month, the power bill is, last month the power bill was $475. This month the power bill is $494. Find the percent of increase. Well, they told you we're increasing, right? So you don't even think about that. But the original amount was $475. We went up to $494. So we know we are increasing. Pause the video now. Try this one on your own. See if you can find it. Remember, new minus old divided by old. Are we going up here? Yes, we are going up. So we know this should be positive. If you flipped it around, you did old minus new, you're going to get a negative number, which means it's a decrease. So always ask yourself, does my answer make sense? And if it's an increase, it should be positive. Decrease, it should be negative. You'll see that when we work at a decrease problem here in just a moment. So let's sub in the new price, $494, minus the old price, $475, divided by the old price. Again, we are comparing the difference to the original amount. That's why we divide by the original price, or the old price, if you will. So 494 minus 475, and we get 19 divided by 475. We make this a decimal, and we get 0.04, which is, move that decimal over 2 spots, and we get a 4%. Was it an increase or decrease? We have a positive number, right? A positive percent, so it should be an increase. So that's going to be a 4% increase. All right, here we go. Try another one here. The population was 257,000. Since it has dropped to 243,000, find the percent decrease. So pause the video now. Try this one out on your own. Our setup is new minus old divided by old. We are always comparing it to the old amount, so we do need the old amount in the denominator. Now, 257,000, you may have worked this out with a whole bunch of zeros in it. It's not necessary because when you do divide, those zeros are going to cancel out. So you could write out all the zeros, you'll get the exact same answer I get, or you could just write 243, that's the new amount, minus 257, that's the original amount or the old amount, and you divide it by the original amount. And when you find this difference, remember this is a decrease, right? So we should get a negative percent. So let's see what we get. 243 minus 257 is negative 14. Negative 14 divided by your original amount of 257. We get negative 0.05. I'm going to round to the nearest tenth. So that's 4, so that's going to be 4 right there. So this is going to be what as a percentage? 1, 2, negative 5.4%. Let me erase that little mark there. 5.4%. Excuse me, my pen's glitching. Okay, or you could say a 0.4%, and then use the word to describe what happened. It's a decrease. So decrease. I would take either of these. That would be okay, or that would be okay as well. We went down 5.4% or negative 5.4%. All right, try this one out. In June, the water level at Lake Oconee was 460 feet. In July, the water level was 437 feet. Find the percent of change. Pause the video now, work this example. The first thing I always do, I always ask myself, are we increasing or are we decreasing? Increasing will be positive, decreasing will be negative. So the water level was, that's the original amount, 460, right? So 460, that is our old amount. In July, the water level was 437. Did we go up or down? We went from 460 to 437. We went down, so this should be negative. New minus old. 437 minus the old 460. Okay, let's work this out now. 437 minus 460, so that's negative 23 divided by 460. If it's a decrease, it should be negative. And we get negative 0.05. What is that as a percentage? It is, move the decimal over 2 spots, boom, boom, negative 5%. So the percent change is negative 5%, or you might say a 5% decrease. Again, when you use the word decrease or increase, don't worry about the signs because the word decrease in this case lets you know we are going down. Lets us know that it's negative. I would take either of those. Try these two. Pause the video now, work these two out. I'm going to flash up with just the answers in a moment. Pause the video. Looking at the first one, a $100 digital watch is now $72. We went down in price, right? We were at 100, now we're at 72. That is a decrease. New price, 72, minus the old price, 100, gives us negative 28. Oh, it's negative. It should be because we're decreasing. If it were positive, alarm bell should be going off that you probably set this up wrong. We divided by the original amount, which is $100. Negative 28 divided by 100, we get negative 0.28. Move that decimal over 2 spots, 1, 2, which gives us negative 28%. This is a 28% decrease. Again, I would take either of these answers. They're both correct. Next one, in April 1996, the average cost of gasoline was $1.54. In April 2008, the average cost of gasoline was $3.60. Find the percent of change. Did we go up or down? We were at 154. Now we're at 360. That is an increase. We should have a positive percentage. 360 is the new amount minus the old or original amount, $1.54, divided by the original amount, $1.54, and we get $2.06. That is your increase, right? Went from 154 up to 360. That's a $2.06 increase divided by the original amount, 154, which gives us 1.338. I'm going to round to the nearest tenth of a percent. So when I round to the nearest tenth of a percent, that's going to be out to the tenths, hundredths, thousandths place. To change this from a decimal to a percentage, remember, decimal to a percent, we are getting bigger. So I got to take that decimal, move it over 2 spots, 1, 2 to the right, and we get 133.8%, or a 133.8% increase. You might be thinking, how can we have more than 100%? Well, this is entirely possible when you are talking about percent of change. You can't give more than 100%. So a common phrase in athletics is, oh, this athlete gives 110%. That's just a phrase that coaches use or commentators use. It is impossible to give more than 100%. You cannot do it. But something can increase by more than 100%, right? So if you had $1 and you earned $2 more, now you have 3, right? You increase your net worth by be 200%. Okay, so you can increase or decrease. Actually, you can increase by more than 100%. You can't decrease by more than 100% because then you would lose everything. Okay, very good. Here's just one example of this. So if you understand what's been going on recently with the virus, it's negatively impacted a number of jobs. So like, for example, if you are an Uber driver, you're probably not driving as much. If you are a waiter or waitress, you're probably not serving as many people. If you're a hairstylist, you're probably not cutting people's hair because they're social distancing, right? So in Massachusetts here, recently, I guess is March 26th, 148,000 Massachusetts residents applied for unemployment. The previous week was 7,449 unemployment claims. To go from 7,449, you have to multiply that by 19 roughly to get to 148,000. So this is an increase of 1,900%, right? You see that down here in Massachusetts. 147,995 applied for unemployment in the week ending on March 21st compared to 7,449 the week before. That's an increase of 140,546 or almost 1,900%. So we have increased the unemployment claims in Massachusetts by 1,900%. That's an astronomical change, but you understand why it's happened, right? There has been a big situation that happened. This is not just a typical 1 week to the next. There's been a big change based off of this virus and how it's impacted society. So this is one example of things that have been going on in the real world that compares to this lesson today. All right, thanks very much for your attention. Good luck on the assignment today. Let me know if you have any questions.